So now we're going to learn about one thing, and I promise you guys that's the last thing on the whole semester, the concept of center of gravity, right? So center of gravity is going to help companies to find the location that they should start looking for whenever they're going to put a plan, right? So sometimes in this exercise, it gives you a location in the middle of the ocean or something like that. But the idea is, well, where should I start looking at, right? Because an example that we did on our last video, we had three options. We either put in location A or in B or in C, right? We didn't thought about all the other places that we can put, right? Maybe there's something between A and B or between A and C or something in the middle there that is actually best because it's the lowest total distance. So center of gravity is a calculation that gives you that point, that kind of good starting point. And we actually used that as well in capstone consultant projects, and the companies were amazed by the work that the students did to find where should they put their warehouses. We kind of provide them a tool they can update, they can put more data on, more delivery routes, and all that. And we did that for two. I did that for two projects. Electrolux last semester also they wanted to know where to put the warehouse with materials from suppliers, and Sunoco for finished good products. Three different, like, as I told you guys, product lines. So center of gravity, it gives you that point, and the logic behind the math is we're going to use a weighted value for the x and y. Okay, so I know that this formula looks scary, but basically you're calculating x and you're calculating y, right, to give you that x and y coordinate. And you're doing that by summing the x of the different places that you're going to deliver by the load of all the times that you're going to deliver there, and divided that by the total load. So it's a weighted value of the x coordinate, and then a weighted value of the y coordinate, weighted by the number of times that you're going to deliver. So it's going to look a lot less scary when I give you the example. Okay, I promise. So x here is going to be 3 because it's the coordinate of C1. Okay, so it's x for C1 times the load for C1, 14, plus x for C2 times the load of C2, so 6 times 10, plus the x of C3, 13, times the load of C3, which is 5. Okay, so as you can see in the math, what we're doing is we're shifting, only looking at C, shifting the point more towards the location where you give more coordinates, right? So if you do an average, 3 plus, let's say, 13 divided by 2, or 3 plus 6 plus 13 divided by 3, will give you another point, a lot more towards 13. But in this case, I'm doing a lot of deliverance in 3. So that x coordinate should be closer to 3 than to 13, because 13 I'm only delivering 5 times. That's kind of the logic behind it, right? Hopefully that kind of clarifies some stuff for you guys. And I'm dividing by the total number of deliveries to have that weighted value, right? Because I'm multiplying here on top, I'm dividing total, get the weighted value of 5.76. Need to do the same thing for y. So I'm taking the y coordinate, so 18 times 14 plus 5 times 10 plus 12 times 5, divided by this sum here. And again, it shifts the y variable towards 14, right? Towards this coordinate, because that's what I'm delivering more frequently. So as you can see here in the kind of problem that we went through from the beginning of the class, we have the red dot here, and we have C1, C3, and C2. And if we calculate the center of gravity, it's going to pull towards C1, right? So it went a little bit to the left and a little bit up to pull towards C1.